Here is an explanation for the answer to final exam question number 88 on page 370 of Geometry Demystified, 2nd edition. Suppose that we want to determine the equation of a geometric line in a Cartesian 3-space coordinate system. Here the x-axis goes to the right in the beige board, the positive x-axis goes to the right. The positive y-axis goes straight up in the beige board, and the z-axis, the positive z-axis, theoretically comes right at you. But I've drawn it in perspective. That is a Cartesian 3-space coordinate system. We want to determine the equation of a line that runs somehow through this space. It doesn't necessarily have to be in the plane of the beige board. It can be coming out of it any old way. It doesn't have to go through the origin. It could be over here. It could be over here. How can we figure that out? What do we need to know? Well, we need to know the coordinates of one point on the line, and then the direction numbers of a vector that runs parallel to this line. It could run right along the line, that's the ideal case, but all vectors that run parallel to this line, this is the one we've picked here, all vectors that run parallel to it will have the same direction numbers. But in order to determine which one of these vectors actually lies on the line, we need to know the coordinates of one point on that line. The correct answer here is A. All of the others, you can check them out and find counterexamples. They don't always work. So the correct choice once again in this case is A. We call these direction numbers. They provide us with what are known as a parametric equation of a line. In 3-space, the equation of a line is a rather esoteric concept. It requires a certain way of thinking that is more complicated than, quite a lot more complicated than a simple plane. But if we know the coordinates of one point and then the direction, the point and the direction, we know the equation of the line. We can deduce that equation from that information.